Oh, so we won't get any chatting beforehand, huh?
I don't know.
Okay.
Participants, okay. Are you in now?
No, I need to get let in by the host.
Okay, I'm in. Okay, so why can't I let you in? Okay, I'm going to call Dan and have him log out and log back in. Because you're in the room or whatever. Oh no, wait.
Okay.
No,
Let me hang up the phone first.
No, hang on. Oh, there we go.
Okay.
Testing 1, 2, 3.
Yep, I can hear you.
Perfect. Yay. Okay,
Yeah.
and then after we get John Henry on, then I'll hide my video.
Okay, so apparently I have to wait until I become the host before I can share. So unfortunately, that's what happened on Monday when we did it with him.
Okay, so let's see. I want to make you the host. Is that what I'm doing?
Well, yeah, but not until after John Henry gets in. Otherwise, I have to watch to let him in.
Okay.
Because we.
I think that you see how there's.
Oh yeah.
I think you see that there's 2 TSM admins.
Uh-huh.
I think that's Dan is the second host. So I think it's really Dan that's going to be letting people in. And notice that we're live on YouTube now.
Okay, well,
Oh, there's John Henry. Good.
Hi, guys.
Hi there.
Hello, John Henry.
Yeah. Whoops. Let's see. Get everything going here. Video.
John Henry, we are live in the sense that there's stuff that if people were logged in on YouTube, they would be seeing. So no swear words as of now.
No swear words as of now.
Yes.
Well, I guess that's good with just the 3 of us.
But there could be people watching on YouTube at this point.
Okay. Well, I just learned this afternoon we're competing with Truckee Town Hall emergency meeting and all, but oh well, that's life.
Exactly.
That only affects the questions. We're going to have it recorded and posted, and we'll be promoting it for those who missed it.
Okay. Well,
Yeah.
Let's see. Something I want to do here is get my presentation ready.
Mm-hmm.
Which seems.
While you do that, I'm going to try and give the presentation capabilities to Ellen.
Okay. Let's see. I have to get rid of Zoom, get into Safari here. Or get into my desktop. Let's see. I don't need that.
Dan, if you can hear me, can you please make Ellen the presenter?
Oh, here it is.
Okay, I'm going to mute myself for a moment here.
Okay, that's all good. Slideshow, start from first slide. Okay, that's showing. Let's see. Now I have to get back in the picture. Oop. Oh, okay. Now, obviously, I'm not sharing screen yet, but I see your title slide.
Great. Dan is indicating that there's some feedback, so I don't know if it's unplugging and replugging our headsets or something like that. Are you still hearing feedback, Dave?
I am not.
Okay.
I am wearing my microphone thing, which should reduce feedback, but maybe it's not. You're hearing feedback.
Okay, I just got the note that we're good now.
Okay. All right. So as far as I know, I'm ready to share screen. So
So I have a few introductory slides, and then I will stop sharing and pass the control over to you so that you can share.
okay.
Because unfortunately, our version doesn't allow us to, as participants, do the screen share, so we have to become the host.
So you're hearing me through my microphone, I assume. I'm not getting very good sound on my end, but
We hear you well. It's coming through.
okay. I guess that's what counts, at least for the moment, till we
It
get to the
is,
question.
and yet every time you touch your microphone, we pick up the scratch.
Yeah, I'll try not to do that. Okay. So we have 15 minutes to twiddle our thumbs. Well,
Yeah, we did a good job of being early and getting it streaming, so that's good.
yeah, important to do that.
I'm going to go over to another computer and see what I see on the YouTube side.
Ah, good. So Ellen, what's the deal? When we're ready to start, you make me the host or what?
So I'll start and present a few introductory slides, and then after that, I will stop sharing and I'll make you the host so that you can share your slides.
Yeah. So you just click on my image and make me host. At least that's one way I know to do it.
Yes. Yeah.
Okay. Well, you have a lovely background there, don't you?
So the Truckee Chamber of Commerce distributed a few images of Truckee that they were encouraging people to use as their backgrounds.
Okay, you know what I'm realizing? I'm not getting audio through my earphones. Okay, say something now.
I'm speaking now.
Ah, okay.
And I did just let Megan in.
Hold on.
Megan, we're live streaming already to YouTube, and we're just using a different set of technology to make it happen this time. So
Do you have
we're live already.
Do you have a link to that you could just ping me real fast? Just make sure I'm watching the right.
I don't, because I'm full screen already with the presentation, but if you go to the Tahoe Silicon Mountain YouTube channel,
Should just be there.
it
Okay.
should just be there.
Okay,
And
let me
once
get
you've subscribed to the channel, in the future, you should just get an alert when it's about to start. I think I got my alert at 4:30.
got it. Okay. I thought I had subscribed, but maybe not. Great.
Hi, Megan.
Hi,
Dave
how
here.
are you?
Good, thanks. I just checked on YouTube. We are live.
Oh, I see it now. Yep. Got it.
How are you?
Good, thanks. I just checked on YouTube. We are live.
Oh, I see it now. Yep. There's a. Got it.
How are you?
Good, thanks.
What's happening?
Okay, for those of you who are doing both, make sure you mute one of them.
I'm logged out on the YouTube on the PC, and you could tell that there was a delay there.
Yes, not very much though.
Yeah. Megan, I'm gonna hide my video so that John Henry and Ellen are the two people that show up on YouTube.
And Megan, I'm afraid I didn't update the slide from last time, so I have email coming to info@. Are you getting the info@, or should I change that real quick? No H, right?
Correct.
I just want to make sure that you're the one who's getting the questions instead of me and not looking at them.
Yeah, I'm just trying to stay muted so I don't mess with anything.
Yeah. I am hearing feedback again. I don't know if I hope that's not me.
Well, as far as I know, I'm being quiet.
Yeah, I muted and unmuted and it wasn't me.
Well, is it coming from me? I don't know. Okay. Now I unmuted myself.
They say it's coming through fine to YouTube, so I'm not going to worry about it.
Ellen, just to let you know, last time I went through this, which I finished a half an hour ago, I got it down to 49 minutes, not 40, but okay, so we got less time for questions, but you know, maybe I'll talk faster.
Sometimes that happens when we go live, but I think that's great. You have well-rehearsed content, and so I think people won't be frustrated if there's a small amount of question time.
Well, there are a lot of things I just took out to make it shorter, but anyhow, I know actually live in front of an audience, yeah, the adrenaline gets going and I get talking faster. This will be the first time doing it this way.
Mhm. Okay, we have about 5 more minutes, looks like. Well, it's 5 o'clock now, so I think it's time to go ahead and get started. Welcome everyone to Mountain Minds Monday, a program of Tahoe Silicon Mountain. We are recording this, and so this will be available afterwards as well, so it is being recorded. We offer 2 different monthly programs as part of Tahoe Silicon Mountain. Mountain Minds Monday, which you're attending now, which is an educational topic and speaker. It happens the second Monday of every month and has been doing so for the last 10 years. Right now, we're offering these programs virtually. When we're back able to meet in person, we'll be up at the Alder Creek Cafe in Tahoe Donner. So for now, we're meeting 5 to 6. The other monthly program is called First Friday at 4, and that happens at Lyft Cowork. Next month, our speaker will be Marcia Ramstrom. She's the founder and director of Lotus Educational Services, and she'll be talking to us about minds at work, managing emotions and conflict, something I know is a challenge for a lot of people right now. We also offer 2 annual events. One of those is Startup Weekend Truckee, which is currently scheduled for the fall. It's a 3-day event for entrepreneurs, and more on that as we get closer to the date. The other annual program is our Pitch Camp and Pitch Showcase. Pitch Camp generally happening in August and the Pitch Showcase in September. For those of you who are not already Tahoe Silicon Mountain subscribers, please do subscribe to the YouTube channel. You'll get alerted when our next presentation occurs. We also encourage you to read our email newsletter. We promise we only send a few emails per month, just a digest of what's coming up. And you can also follow us in the Facebook group where you'll have a chance to interact with other Tahoe Silicon Mountain members. One of our principles at Tahoe Silicon Mountain is making events accessible to everyone, and we do that in several ways. One is this live stream. So if you look back through the channel, you'll see many of our past speakers. When we are meeting in person, we offer a pay what you can model to make sure it's accessible to everyone. We have sponsors who make it free for local high school students with an ID. We also make it free for those of you who volunteer to help put on the events, because we are a 100% volunteer organization. So here's a short URL to sign up to volunteer for when we're back to meeting in person. For this virtual event, we do have a suggested donation of $5. You can just go to TahoeSiliconMountain.com and you'll notice in the upper right-hand corner, there's a donate button. You can donate one time or set up a recurring. So why donate even for these virtual events? As I mentioned, it is a 501c3 and we're 100% volunteer run. We do have expenses to keep it a 501c3 related to bookkeeping and tax filings, live stream coordination, different technology subscriptions, getting the word out to you, and some of the event costs when we're meeting in person. So again, please be generous with the pay what you can model. We would love if you'd make a donation. Thank you. We have a board of 5 board members, and we're excited about continuing to expand the events that we offer to you. These are the members. We're always looking for more people, both as volunteers and as future board members. I'd like to take a moment to thank the sponsors who helped make this happen. Our gold sponsor, and has been a gold sponsor for us for a very long time, is the Holland and Hart Law Firm. We also have a silver sponsor, which is Mobo Law, and quite a few community partners that help enable this. So we have Nevada County Tech Connection, Tahoe Truckee Media, who's helping us stream this now, the Truckee Tahoe Airport, who has provided some grant funding, Lyft Cowork Space, which allows us to hold some of our events there, the town of Truckee, and Tahoe Donner, where we hold our in-person Mountain Minds Monday. You too can be a sponsor. Here's a short URL, or if you'd like to reach out by email, sponsorship@TahoeSiliconMountain.com. So without further ado, I'd like to move over to the main event, Climate Change, Science and Solutions. And I'm going to have Dr. John Henry Beyer introduce himself and get started. So I'm going to take a moment to pass over control so that he can start his presentation.
Oh.
So you should now have host responsibilities and be able to share your screen.
Yes, okay. Share. Okay, there we are. I didn't realize I was introducing myself though, so now I'll launch into it. I have a bachelor's degree in physics and a master's in geophysics, and then went to UC Berkeley for a PhD in geophysics. My research involved development of technologies to explore for geothermal energy for electricity generation. And this ultimately led to management of a 50-employee geophysical exploration company and subsequent consulting jobs managing geothermal exploration projects in Japan, Indonesia, and the Azores. But then I kind of switched topics still within the career of geophysics. I've been in research management, developing technologies to mitigate climate change. First at the California Energy Commission, and then more recently back to Lawrence Berkeley National Laboratory, where I originally worked as a grad student. At Berkeley Lab, I was working on the geologic storage of carbon dioxide to keep this greenhouse gas out of the atmosphere until we can stop releasing fossil fuels by burning, stop releasing greenhouse gas by burning fossil fuels and keep them out of the atmosphere. I retired from Berkeley Lab in 2014 and moved full-time to Truckee after many years of coming up to ski from the Bay Area. So now I live here full-time. I did want to mention a little prelude before I really get into the talk. With the coronavirus now and the killing of George Floyd and the resulting protests and ramifications, it leaves me wondering how many crisis situations our mental energy can deal with. How can we take the time and effort to address global warming? I really don't know the answer to that, but it is another looming crisis. Its approach is not as abrupt as the pandemic, but the long-term ramifications will have destructive impacts for life on Earth. It's that serious. So I'm going to present some scientific evidence, even though I recognize that scientific evidence doesn't really change people's minds. But I will explain some of the science because, well, if you have some doubts, if you have a conversation with someone using denialist talking points, hopefully you'll at least have a better understanding. And after that, I'll suggest some helpful things that we can do both individually and collectively. So now let's dive in. Certainly in the past, you saw that many environmental organizations used images like this, the plate of the polar bears with the ice melting, the ice flows giving way, and that's where they live and that's where they hunt. And it's real, it is sad for the polar bears, but it gave people the impression that global warming is in a time and place far, far away. And nothing could be farther from the truth. And I put this image in just to suggest it's happening to all of us. It's happening here and now, all over the world. And it's going to be worse for them. Who are they really? This just represents perhaps your children, perhaps your grandchildren, whether or not they're born, and future generations. Unless we get moving on this, it'll just keep getting worse for them. So we do have to take action. We live in this wonderful place. There are just some images of this place we love, but we do understand, certainly without a doubt, that we are threatened here. The long-term, on average, drought has been drying the trees. The bark beetles have taken over, killing swaths of the forest. We're all well aware of this living here, and none of us wants to be like this guy on the roof of his house watching the flames approaching. But more than that, during these fires, often the smoke has moved up here, and this smoke is hazardous. The small particulates in the smoke, PM 2.5, that's particulate matter 2.5 microns. They're very small particles. They get in our lungs and they don't get back out. That's hard for us, hard on us, our bodies. And think of it in terms of, well, if homes burned and cars burned, the toxins that are in that smoke, toxins from burning oil, gasoline, tires, paints, plastics. And here are two images of Lake Tahoe, the Tahoe Basin, and two fires about a year apart in this smoke. Not good for us. And then there are the threats of the vector-borne diseases, mosquitoes and ticks. Look, I made this slide and I genuinely have a hard time looking at it. I hate these critters. But they are migrating north in the Northern Hemisphere from more tropical areas because it's getting too warm there. And they're also moving to higher elevations up the mountain where it's a little bit cooler. So they're moving our direction, whether it be Zika, dengue fever, West Nile virus, Lyme disease, Rocky Mountain spotted fever. They're marching our direction. And in terms of enjoying our lifestyle here, well, skiing is fading away. Here's a chart of the reduction of the ski season in 5 mountain ranges across the United States. And the light blue is the average length of the ski season back in 82 to 86. And 30 years later is the dark blue. So over 30 years, well, in the Sierra here, ski season was reduced by 27 days, nearly a month. And that's continuing to happen. And furthermore, estimates are made that by the end of the century, 2100, the average snow and rain elevation on the mountains will be 950 feet higher. So imagine wherever it is you like to ski, that bottom 950 feet of elevation of the runs probably won't have snow on it. Now, granted, it's not going to bother somebody of my age, but in terms of children and grandchildren, well, it is going to affect them. And speaking of things like water or snow, in this case, hurricanes and cyclones, they're getting more violent and more intense. But why is that? Well, global warming is heating the land. It's heating, on average, the atmosphere and the oceans. So the ocean's getting warmer. That solar radiation is coming in and warming the surface waters first. And these storms, these hurricanes, they get their energy from warm ocean surface water. That heat is energy. And so the storms get that energy, which is why the wind speeds are getting higher. And warmer near surface ocean water means there's more water vapor above the ocean in the air. And the storms pick up all that extra moisture and later dump it as rain. So that's why we have tremendous deluges of rain and stronger wind speeds. And furthermore, sea level is 7 to 9 inches higher than it was in pre-industrial times. And so that means that the storms are inundating more land. But on top of that, of course, the winds push the ocean waters up against the land. So there's storm surge, so that locally it increases the effective sea level even much higher. So it's this combination of events that makes these storms much more violent. So what's really going on here? The greenhouse effect. You've heard the term, I'm sure. And, you know, in the media, they talk about it and they just say, well, it's like putting a blanket around the earth. And well, in a sense, that's true. But scientifically, what's happening? Well, radiation is coming in from the sun. It's broadband from infrared, the low frequency, to ultraviolet, the very high frequency. The tiny range we see as visible light is just a tiny portion of it. So some of it bounces off clouds back out into space, but of course, a lot of it hits the earth and the oceans, and it warms them. And a lot of that heat now where it warms the earth. I mean, think of an asphalt pavement on a hot day, right? It gets really hot. Well, that's sending infrared, the low frequency radiation, back up toward the sky. Some of it goes right back out in space. But over here, we've got this red arrow coming up, and there doesn't seem to be anything in that little space there. What's there is a molecule of a greenhouse gas, carbon dioxide or methane, and a couple others I'll mention later. But it hits that molecule, that infrared radiation, it warms the molecule. Now it emits that heat in all directions, some of it back out to space, but a lot of it right back toward Earth. So it hasn't escaped. Now, the greenhouse effect is good, but we've got too much of a good thing. The reason it's good is that it's because of the greenhouse effect, and there has always been carbon dioxide in the atmosphere to give us greenhouse effect. The reason it's good is it's kept the entire planet from being covered by ice. It allows us to live here on the surface of our Earth. But we've got, shall we say, too much of a good thing here. So if that's happening now and we're changing that, we're trapping extra heat because of all of our emissions of greenhouse gases, how do we know this really is different from what happened in the past? Well, there's a tremendous amount of excellent evidence from ice cores. Some of them are drilled in Greenland, the deepest ones in Antarctica. And there are places in Antarctica where you can drill more than 2 miles deep. And when you drill that deep, you're getting ice, which was originally snow, laid down as much as 800,000 years ago. And here's a drill rig in Antarctica. And they're bringing out core of ice. And this is an example of it here in the right picture, an ice core. So as the drill goes deeper and deeper, it's collecting samples of ice, which are originally snow, laid down. The snow never melted. More snow went on top and more snow on top of that. And it just got compressed into ice. And of course, there's lots of air around snowflakes. And so there were bubbles of air now trapped in that ice from that same point in time. And ice, well, it's H2O, it's water, it's just frozen. But there are isotopes of oxygen and hydrogen. And interestingly, from that ice, we can actually learn about the temperature, average temperature of the Earth that existed back at that point in time as we drill deeper and go farther back in time. And the air bubbles, we can sample those to get the concentration of carbon dioxide, CO2, at that point in time in the past. And we can do radiometric age dating to really identify those ages of each level of ice. And so now I'm going to show you some of the data from the ice cores in Antarctica. So first I need to explain the scale. We are now at time 0 here. This is today. And when we look to the left on this scale, we're going back in thousands of years. So all the way back here on the left, this is 800,000 years ago. As I said, we can get ice cores that are that old. And blue is temperature and how it's changed over that period of time. And what do we see? Well, we're here, but here was a cold period and then a warm period and a cold and warm and cold and warm. And that's happened. Well, you can count them 1, 2, 3, 4, 5, 6, 7, maybe 8 of these warm and cold cycles. And these are called Milankovitch cycles, just named after the Serbian scientist and astronomer who figured out what was causing these warm and cold cycles. What was causing them was the positions of other planets in our solar system moving the Earth's orbit closer or farther from the sun. And when it was closer to the sun, we had a warming period. And also now on the orange and the right scale, it was the amount of carbon dioxide in the atmosphere from these cores. And I put a dashed line across here at 300 parts per million. And we can see that over this 800,000 year period, The carbon dioxide has never been above 300 parts per million. Now, 300 parts per million, that doesn't sound like much, and in fact, it's not very much. It's 3/100ths of 1%. The fact remains, it does have a profound influence because those molecules of carbon dioxide absorb heat. And it's gone up, and on this time scale, it looks like a vertical line, the amount of carbon dioxide in the atmosphere. It's now up at 415 parts per million on average, well above this 300 level. Now, the next slide I'm going to show you is looking at a time scale just from early industrial times to the present, about the width of this little black line here at the bottom right. Here it is. So now, in detail, we see from about 1850 on the left up to the present on the right. And once again, blue is temperature. And now that we can see details, we can see it's gone up and down and up and down and up and down. But what's happening here is rather complex change of where the heat is going in our whole Earth system between the atmosphere and the oceans and the land. But I inserted in black up here 6 little dots, which are the 6 most recent years, and including the last one for the complete year of 2019. And you can see that these are the warmest years in our recorded history of the average temperature of the Earth. And here's the carbon dioxide line. And down here is the 300 that I had on the prior slide you saw. Now, I want to point out this area right in here, where on average it looked like the Earth wasn't getting warmer. And the climate change deniers say, hey, look at that. Look, the Earth isn't warming after all. Of course, they were ignoring this entire curve. But initially it had the scientists baffled too. It's like, because they knew nothing had really changed. The heat was coming in from the sun. There was no change in our orbit. And what was going on? Well, of course, they were measuring temperatures on the land and on the near surface of the ocean. So they started looking deeper and deeper in the ocean. And what they found was there were currents that were circulating that warmer surface water down deeper in the ocean. And so during this period, they just weren't measuring it, but the heat was still coming in. And then that trend stopped, and we got these 6 warmest years. Now, in this chart, the black line represents the blue one on the prior one. It's the observed data for the average warming of planet Earth. And I want to talk about the various things that can, in fact, influence the temperature of our Earth. And there are natural things that can do it. So let's start at the bottom one here, orbital, in this reddish brown line here. Well, that has to do with those Milankovitch cycles. That has to do with other planets affecting Earth's orbit in our solar system. And other things included in this are the tilt of the Earth's axis. That does affect it as well as the precession of the Earth's axis. Think of a spinning top, and it precesses as it slows down. But you can see that from early industrial times, we're here at 1880 up to the present, that brownish line through there has almost no effect. Then there's solar radiation from the sun. Well, you know, that does change over time, but that's the purple line through there. And we can see that from early industrial times to the present, there's been virtually no significant change. So the deniers say, oh yeah, it's volcanoes. Well, volcanoes have 2 effects on the temperature of our planet. One is that they can put out a lot of carbon dioxide, which tends to have a warming effect, but they don't always do that. They have a second effect of putting a lot of particulate matter into the air. And those particulates, as I mentioned earlier, reflect the solar energy back out into space, and they have a cooling effect. So I've named some major volcanic eruptions here, and they're all associated with cooling. You see the low greens here going across. And if we put all these natural, scientists call them drivers, they're just pushing the climate warmer or colder. Influences, I called them in the title up here. we add them all up, we get this gold line through here. And we can see that they cannot come close to explaining the actual observed data for global warming. So now let's look at the human things that are affecting our climate. Well, aerosols. Well, that's dust particles from transportation like cars, trucks, airplanes, whatever. But as I said, that reflects light away from the earth. And so you can see it has a cooling effect. Land cover. Well, if we take the Amazon rainforest and cut down a bunch of the trees and turn it into pasture for cows, instead of dark green, it's a much lighter color. That has a cooling effect because it reflects some light away. Ozone. This is ozone at low levels in our atmosphere. It's smog in our cities. That does absorb some heat and have a slight warming effect. Now up here in purple, we have the greenhouse gases. Now there are various ones. Carbon dioxide, CO2, is the one we're emitting the most of, but then there's methane. Methane is the primary gas in natural gas we use in our furnaces and water heaters. And a lot of that natural gas leaks from the oil fields, gas fields, and a lot of it's methane. And that's considerably worse than the carbon dioxide in terms of global warming potential. It's just that we don't release as much of it. Nitrous oxide, that's in fertilizers predominantly. And fluorinated gases, those are the gases that are in our refrigerators and freezers and air conditioners. So when those go to the dump and those gases leak out, they can be tens of thousands of times worse than carbon dioxide. It's just that fortunately we don't release quite as much. So that's the purple line. Now, when we put all of these human drivers or human influences together, we get this red line. Now we're starting to match the observed data really well. So now let's put it all together, the human and natural. And here we get this orange line in here. And we've done a pretty good job of fitting the observed data for our planet's overall temperature increase since very early industrial times to the present. And also the data I showed you really demonstrates that we are the ones doing it by releasing these gases into our atmosphere, because you take all the things that can change it and we see what it takes. It takes the human release of greenhouse gases to be able to fit the observed data. Now, when I first heard about global warming, I was a grad student at Cal. And I thought, oh, come on. How can we little people be changing the climate of our entire planet? I mean, after all, those gases are going to the atmosphere, but the atmosphere looks huge. You go out, you look up, you see something like this. Well, since then, I've learned a lot. I wasn't really studying this aspect of geophysics at the time. And so when I actually give this talk really live in front of an audience, not virtually, I bring out this globe here. It's a blow up globe. It's 16 inches in diameter. I call it beach ball Earth, but I also have a regular 12-inch ruler here. And I ask people to shout out, hey, at this scale of a 16-inch globe, how thick do you think our atmosphere is? And I'm going to ask you too, although I can't hear your answers, but pick a number. I've heard anywhere from 4 inches to a 1/16 of an inch. Well, here's the answer. The thickness of our atmosphere is about the thickness of my ruler, 1/8 of an inch. That's it, our entire atmosphere. And here's a picture of it, a lovely scene of sunrise from the International Space Station with this fuzzy blue line on the horizon. That's our atmosphere. The atmosphere is regarded to be about 100 kilometers or 62 miles thick. There's political dispute over that. There are political implications, but that's really a reasonable number that many regard as accurate enough, because of course it just fades away gradually, bit by bit. But that's it, 62 miles up is it. So at the scale of my beach ball Earth, the bottom layer of the atmosphere, the one we live, one called the troposphere, that one is only about the thickness of a filing card. Now, why is this troposphere important? That bottom layer contains 75 to 80% of all the atoms and molecules in our atmosphere. And it varies between about 5 miles and 12 miles thick, but on average, it's about 7 miles. Now, remember I said that whole atmosphere is regarded to be about 62 miles, but this layer we live in and where all of our weather is only on average about 7 miles thick. And on my scale of a 16-inch globe here, it's the thickness of this filing card. And most of our pollution, whether it be what we normally think of pollution or greenhouse gases, whatever, that's where it's all going. And that's where most of it stays. So I'm trying to give you the impression this is in fact a tiny, tiny space it's going into. Basically just a smudge across the surface of the whole Earth. And so how much of, in this case, just carbon dioxide are we emitting? Well, for the whole last year of 2019, global emissions were 37 billion metric tons. Now, I don't have any way to really mentally grasp what a number like that means. And just for your information, the scientists, instead of the word billion, they use the word giga. It means the same thing. Think of the word gigantic, same root here. And a metric ton is spelled T-O-N-N-E. And a metric ton is just 10% larger than a US short ton. A US short ton is 2,000 pounds. A metric ton is 2,200 pounds. And the scientists abbreviated as capital G, small t. Now, if I divide that by 365 days in a year, I get over 100 million metric tons a day the people of our whole planet are putting into that tiny layer, the troposphere. And still, how do I get a mental grip on that? Well, I decided to compare it to the weight of the Empire State Building. And it's not like I know the weight of the Empire State Building, but people have estimated that it weighs a little over 330,000 metric tons. Well, if I divide that into my 101 million tons a day, it means that the carbon dioxide emissions that we're putting into the atmosphere equal the weight of 305 Empire State Buildings every day, mind you. So if it's starting to sound a lot, well, it is, and that's exactly the impression I'm trying to give you. So I did make this slide, which we can't dwell on, but I broke it down by country. These are all little Empire State Buildings. So every day, China is putting into the atmosphere the weight of 90 Empire State Buildings. We're about half that in the United States at 44. The next biggest country is India. This is combined for all the European Union. So that's the situation we're dealing with. Now, we've had two major reports released late in 2018. In October 2018, the Intergovernmental Panel on Climate Change issued finally, because they've been putting out reports for a good number of years, basically an emergency report saying we have, originally they said 12, now we're down to 10 years to cut global greenhouse gas emissions by 40%, to limit warming to 1.5 degrees Celsius, which is 2.7 degrees Fahrenheit. And they picked this number because they figure, well, you know, we can adapt and deal with it without horrendous amounts of damage, even though storms are creating billions of dollars of damage every year. It's going to be hard to reach that target. Now, the climate change deniers made fun of this and said, oh yeah, they're saying, well, the world's going to come to an end in 12 years or now 10 years. No, that's not what they were saying. They were saying we need to get on a glide slope at this rate to get down to zero net emissions by mid-century. That's 2050. That's coming up real fast, but that's what they said it's going to take to do it. And that's going to take dramatic action. Now, only a month later, the US Global Change Research Program, which has been turning out reports every 4 years, issued its 4th National Climate Assessment with scientific input from 13 US governmental agencies. This looks at the specific impacts this climate change is going to have on various portions of our country. It may be in terms of flooding or drought or coastal damage. They break it down by the country and look at the impacts. It's a very interesting report, but basically the important thing is the same. We need dramatic action. Now, what a lot of people don't understand is the scientific consensus on global warming. The consensus is overwhelming that global warming is real, it's happening now, and human activities are the primary cause. And I hope you got it, that that's what I already showed you, of the things that can warm our climate. But relatively small percentage of Americans know that more than 90% of scientists agree with this. And furthermore, there's been a study of actual peer-reviewed articles by climate scientists specifically, and there's a 97% consensus. Now, here in the blue, that's 97%. It means that only 3% deny this consensus or are unsure. Well, I can assure you of something, and that is that these 3% are predominantly people who make a living or their pension from the fossil fuel industry. And I know the guy who did this study. I've been in seminars with him at the American Geophysical Union meeting in San Francisco. He's repeated this and keeps coming up with the same answers. It's 97% consensus. Now, here was a prediction made by a group of scientists in 1982, 38 years ago. Now, I know you can't see the details on this graph, so I've put in some big numbers and the red lines, but the diagonal curve on the left is CO2 concentration in parts per million. And they did this study, as I said, starting in 1982 here. They went back to 1960, but they issued the report in 1982 and predicted from there to the future. Well, here we are at 2020. We go up here and over, and this predicted we'd be at 920 parts per million. Well, as I mentioned on an earlier slide, we're at 415 or so. So they were pretty darn close. And they predicted also that compared to 1982, it would be almost a degree Celsius warmer for the average temperature of the planet. Or if I take that back to 1850, early industrial times, that'd work out to 1.3 degrees Celsius warmer, 2.3 Fahrenheit. Well, it's actually about 1.1 Celsius or 2.1 Fahrenheit. Again, very close, very accurate was this prediction. And if I just take this out to the extent of their study out to 2080, 60 years from now, it predicts 615 parts per million. And well, compared to 1850, more than 3 degrees Celsius warmer, 5.5 Fahrenheit. I can assure you that if it gets up in this range, huge parts of our planet will literally be uninhabitable by people. So who were the scientists who wrote this report 38 years ago? Greenpeace scientists and activists, a bunch of tree huggers? No. This report was written by Exxon scientists. It was an internal, confidential briefing report that was leaked 5 years ago. So if you doubt the things I'm saying, will you believe the Exxon scientists? Furthermore, Shell scientists did a similar study 6 years later in 1988, of course, as a confidential report. It got disclosed 2 years ago, and they came to similar conclusions. So the Shell report in its summary said these changes may be the greatest in recorded history. The Exxon summary said this problem is not as significant to mankind as a nuclear holocaust or world famine. Well, I don't take a lot of comfort in that. And what's happening now? Well, you recognize these symbols here. And just for example, during the 2017-18 midterm election cycle, for over a period of 2 years, the fossil fuel industry spent almost $500,000 per day on average to delay, control, or block climate policies. Basically, they were buying politicians. Now, let me switch to a different topic. If you take this seriously, all the things I'm saying, many regard this as regarded as traumatic information. It really paralyzes people. That's how psychologists regard it. And they're starting to talk to the scientists like me and say, look, you know, this really stops people in their tracks with these stages of grief or how to deal with traumatic information, with denial, anger, guilt, hopelessness, helplessness, guilt. If only we worked on it decades ago. Well, we should have. Hopeless. It's happening, but I'll be dead before it's bad. Well, look, I must confess, that's true of me, but what about those future generations? And hey, I'm here talking to you. And helpless. This is a biggie. It's a global problem. What can I do? And that's tough, but there are things we can do. But I want to say that if you have any kinds of these feelings about this information, your feelings are right. There's nothing wrong with your feelings. It's normal. It's a normal response to traumatic information. Now, it turns out that there's a program at Yale University and George Mason University. They are working together, collaborating on taking polls of the attitudes of Americans about global warming and climate change. And we see 73% of people in the polls say it's happening, and only 10% say it's not. And actually, there's lots of very interesting detail. I suggest you go to the site and look it up. And the same high percentage agree that it's going to harm future generations. A lower percentage say it's caused by human activities compared to natural changes. But I'm optimistic about these last two figures. 2/3 of Americans feel a personal sense of responsibility to help reduce global warming. And that's good. And almost the same percentage say it's not too late to address it. So I see that as a sign of optimism. We can motivate people and get them taking action. Now, we are making some progress. I put together this chart from tables of data that are kept and collected by the U.S. Energy Information Administration. Sorry, get myself tongue-tied here. But I pulled data out of it, and I wanted to look at the change in our electricity generation over 10 years. So the red bars are 2009, the green are 2019. So over this 10-year period, tremendous reduction in the use of coal to generate our electricity. And that's good because, well, coal's bad for a lot of reasons. It puts out huge amounts of carbon dioxide, but it makes for acid rain. The sulfur in it's bad. It puts particulates in the atmosphere. So that's gone from almost 45% over 10 years down to about 23. Most of that's been made up by burning natural gas. And this is strictly driven by economics because natural gas is so cheap. But not all of it's been made up by natural gas. Nuclear stayed about the same as 20% of our electricity generation. Here's hydroelectric. This is big dams. And I don't really think we're going to be building any more Hoover dams. So here's wind generation increasing over this 10-year period. It's gone up by a factor of 4 to maybe 7%. That's great. Solar, you can't even see it at this scale 10 years ago, and now that's up to maybe 2.5%. That's good. Geothermal stayed the same at 0.5%, biomass at 1.5%. So, you know, thinking about this, what's got to happen? Well, we've got to get coal down to zero. It's a terrible thing to use, even though it's cheap. And natural gas is sort of a bridging technology, but we've got to get rid of it too, because it still puts out a lot of carbon dioxide, just half as much as coal. And in fact, with increased production of natural gas in the fields, there's a lot of leakage of that gas into the atmosphere. And as I said, natural gas is mostly methane. So, you know, we've made progress, but we have a ways to go. But there are things all of us can do to help. Simple things. Hey, when you leave a room, turn off the lights. If you're going back in 5 minutes, that's okay. Turn them back on. Don't waste the electricity. When I gave this talk, almost a year ago, someone in the audience I know said, "Oh, you never mentioned clotheslines." So I looked into it and I found that our clothes dryers, whether they're gas or electric, are the third biggest energy hogs in our homes after our furnaces and our water heaters. So I started using a clothesline. Works just fine. You can't use it all the time up here in Tahoe, but a lot of times it's very dry, even if it's cold. It works just fine. If we can walk or ride a bike, that's good. Better for our health. Put solar PV on your house if you can, if you have good sun exposure. The house I bought here in Tahoe Donner already had solar PV on the roof. It's great. Over the course of a year, I generate more electricity than I use. ICE, internal combustion engine, car. Well, see if you can drive a bit fewer miles. Plan your shopping trips. Try not to make a trip just to the store just to buy a gallon of milk. Keep your tires fully inflated. You'll get better mileage. Check the tire pressure. And if you can, buy an electric or hybrid car. I did buy a Tesla Model 3. It's the little one. It's great. Years ago, I did inherit some Chevron stock. And in fact, I kept it for a number of years and it was a good stock. And I sold it to buy my Tesla. And I kind of feel good about that. Install LED bulbs in your home. Hey, you'll save 85 or 90% of your electricity for lighting. They're great now. They're not very expensive. They're instant on, dimmable, no hum. They last for up to 20 years. And if you like the warm color you get from incandescent bulbs, and I do, that's what we're all used to really, look at the side panel on the box and get the warm 2700K. Then there's food waste. Hey, try to eat everything in your refrigerator or compost. That's hard to do up in the mountains here because worldwide, 30% of food is wasted. And in America, we waste 40% of our food. What happens to it? It goes into landfills down deep and decomposes. It's anaerobic, that's to say, no oxygen, decomposition, and it releases methane, which seeps back up. And as I said, that's a much more powerful greenhouse gas. Over 20 years, it's about 80 times as bad as carbon dioxide. And if food waste were a country, going back to my Empire State Buildings, it'd have the equivalent effect of 30 Empire State Buildings. And you see this term because it's methane we're talking about here, but it's all, everything's compared to carbon dioxide. So carbon dioxide equivalent would be 30 Empire State Buildings. And something running competition with that is beef. Well, you know, a lot of places around the world, hey, they'd like to have as much beef as we do. And if their economies improve, they want to buy beef. So large parts of the Amazon forest are being cut down and turned into pasture for cows. Well, cows are ruminants. They have a complex 4-compartment stomach that lets them digest the cellulose in grasses. We can't eat grass. were not designed to do that. The cows can, but in the process, they release large amounts of methane, front and back. This is the chemical symbol for methane, CH4. But in fact, most of it is belching, and they do a lot of it. And as I mentioned, the Amazon's being burned down. That's putting all that carbon dioxide into the atmosphere, and of course, reducing the number of trees that are absorbing carbon dioxide. So as I mentioned, cows, if they were a country, would be competing with food waste as number 3 after China and the United States for our carbon emissions. So I talked about various things you can do, but here's the last one, which is really important. And it involves other people, which is why I say together up here. Talk to people. I gave an example of solar collectors, but actually people have observed that at least in subdivisions, if one homeowner puts solar collectors on their roof, within a year or two, a lot of other surrounding homeowners put solar collectors on their roof because it sparked a conversation and people got motivated and they took action. And my example of clotheslines, hey, if you put a clothesline up and you're kind of embarrassed that your neighbor's going to see it and they don't want, you don't want them to see your clothes out there hanging on the line. Well, go have a polite conversation with them and say, well, you just learned that it's the 3rd largest energy hog in your home, and you're trying to do your small part to reduce your greenhouse footprint. And, maybe they'll take action too. So please talk about it. Global warming and climate change. I'm not saying have a fight with your neighbor, but if you can have a polite and informed conversation, do it because it gets people thinking. So with your friends, your neighbors, club members, church members, and especially political leaders, we have to demand it of our political leaders. The other thing you can do that's really a collective action is work with Citizens Climate Lobby. It's a volunteer-driven, bipartisan organization. In fact, they spoke last year at Mountain Mines Monday. Up until COVID-19, they were having members of Congress. Here was just last summer, the people who went to Washington, D.C. for their conference, and they had arranged meetings with their members of Congress to talk with them politely, but encourage them to take action on climate change. They write op-eds and letters to the editor, and there is a local CCL chapter right here in North Tahoe CCL at gmail.com. And here, citizenclimatelobby.org is the organization's website. And what are they advocating for? Specifically, the Energy Innovation and Carbon Dividend Act, House Bill 763. What would that do? It would put a price on carbon at the mine, at the wellhead, or at the port. The government would collect the money, but government would not keep the money. It would return that money to American citizens as a monthly dividend check. And yeah, if you're going to put a price on carbon, everything has a carbon footprint. So prices of things will go up, but people in the lower 40% of the income spectrum will actually get at least break even or make more, and they can spend the money any way they want, but it gets them thinking about it. Gee, what can I do to reduce my carbon footprint? After all, I'm getting a check in the mail. And for the wealthiest among us, hey, it's not really going to make much difference. We would still get a check, but it doesn't make a lot of difference to us. That's the fact. And now just a little bit of a comparison with the pandemic and the climate change. There are some parallels here. Both are disrupting life as we know it, and we can limit that deduction. We just have to get to work on it. Look, the biology, the chemistry, and the physics aren't going to change. We can't wish them away as a hope. We need to trust the experts. I think we've learned that in the pandemic. We need to trust the epidemiologists and the doctors and in other aspects of our life. If we have a legal issue we need to deal with, we go to an informed person, the expert. We go to a lawyer. If a tooth bothers us, we go to a dentist. The science of climate change is the same thing. The scientists are telling us what we need to do and what the responses are and what's going to happen if we don't. So I tried to give you some individual actions and collective actions that are essential for our success. And we do need to move quickly, ASAP, to minimize the damage. And my last comment here, whoops, I didn't even mean to do that. I'm going to have to back up one. I clicked on my mouse, but this should be obvious, and it's not intended as a political statement. It's just that obviously we need social solidarity on this issue, and we need a government that understands all of these issues above. That's how we make it happen. So now to this slide of our Earth here, and I'm real close to just taking questions, but the question mark also represents a question mark for you. What can you do? I'm asking you to think about it and try to find ways that are meaningful to you to take some action here. And I want to leave this slide up for a couple minutes while we do some questions. Here, it's a cartoon at a climate meeting saying, this guy saying, hey, what if it's a big hoax and we create a better world for nothing? Well, yes, it would be a better world. We would have cleaner water, cleaner air, healthier children. The kids with asthma, we'd probably have a lot less. We'd have more livable cities and tremendous opportunities for green jobs here. So I'm ending now. I'll just leave this slide up and maybe I have to turn it back to Ellen. Let's see.
Thank you so much, John Henry. It's amazing how you were able to simplify it in a way that should make it easy for anyone to understand. I'm excited that this is recorded and can be shared around. For those of you who are listening live, you can ask questions either by typing them into the YouTube channel or sending an email to Megan, MEGAN, at TahoeSiliconMountain.com. So either a comment in the YouTube channel or an email to Megan, no H, at TahoeSiliconMountain.com. So Megan, do we have questions ready from the audience?
We do. We've got a question from Dave and Rachel. How have the COVID pandemic stay-at-home orders affected our greenhouse gas emissions?
They have reduced them, but surprisingly, not as much as we would have expected. I have read articles saying it's reduced them maybe 10 to 12%, at least in the United States. I don't know that that's a worldwide figure. I actually would have thought it would be more, but as we move back to what we regard as life more like normal, of course, that's going to pick back up. I can hope that this is, kind of opened people's eyes, at least in cities where there tends to be a lot of smog, that, hey, it's really nice to have cleaner air. Maybe it will motivate people to think about this more seriously, that we can reduce our emissions and have more livable cities. So it's a hope.
Megan, any other questions?
I was just going to tell anyone else with any additional questions. We'd love to hear them.
I guess not.
I'm curious if there's anything else Tahoe specific that we should be thinking about. I really liked that you started by explaining what was going on with forest fires and the impact and the impact on our ski industry. Anything else we should be thinking about that affects us specifically here in the Tahoe area?
Well, yeah, I hit the fire issue, but that's not a surprise to anybody. The insects, those critters. What else? Well, I guess just the overall variability of our weather as we, this morning I woke up to snow. Global warming doesn't mean that everything is always warmer. No, I'm talking about average temperatures, but the climate system of the whole Earth is getting disassembled as a result of this. That's not answering your question about Tahoe. Maybe I need to spend more time thinking about specifically Tahoe.
Well, I think we're coming up on 6 o'clock already, and I want to thank you, John Henry. You've been a longtime member of Tahoe Silicon Mountain, and it's so exciting to have a chance to hear you present. And we're looking forward to getting this out distributed amongst our over 1,500 members. So we should expect to see the YouTube viewings increase quite a bit. For everyone else who's on the phone, thank you for participating, and we look forward to seeing you next month. Again, it's always the second Monday of the month for Mountain Minds Monday. We are expecting our July one will be virtual again, so make sure you subscribe to the YouTube channel and see us back here next month. And thank you again, Dr. John Henry Beyer.
You're welcome.
Okay, so I think you have to hand control back so I can stop the recording.
Let's see. I'm looking for the control. Oh, there it is. Now you're the host.
Great, thank you. Okay, so the recording has stopped. Thank you
Okay.
so much. This was wonderful. I really enjoyed how well, how easy it was to follow along, and looking forward to sharing this with lots of people.
Well, I'm looking now that there were 13 on chat. Maybe that was the total number of people.
I think it's fluctuated through the time. I've seen, that's how many on chat maybe, but I think I saw as many as 20. Yeah.
Well, maybe a lot of people were on the Truckee Town Council meeting that started the same time as we did. So, Dave, can't hear you.
Dave, you're on mute.
I think we may still be live on YouTube. So why don't we hang up? I think is what we should do here at this point.
Okay.
Sounds good.
But well done, John Henry. Well done.
Okay. Thank you.
Yeah.
And Ellen.
Thank you.
Yep.
All right. Bye for now.
Bye.